Okay, continuing with section 6.3. This is number 6. The question asks in the homework outline, which of the following functions is even? On the third page of the theorems outline, you had a list of which functions are even and which are odds. The ones that are even are cosine. There's only two of them, the cosine function and the secant function. Okay, so and you can write that here, the cosine function and the secant function. Everybody else is odd. Okay, moving on. Now let's go back to the theorem page because I believe the theorem page said that we could do numbers 5 and 6 after introducing the odd and even functions. We've done that. And now we're at the bottom of this page where I want to remind you something that I pointed out in previous sections and will keep reminding you as we try to evaluate these trig functions. So I wanted to remind you that when you're in this quad, because remember, you're going to be rotating around the circle to create a triangle. Every triangle that you create has an associated X and Y value. The Y value is the leg on the triangle that you're going to create, the leg that runs vertically up and down, and the X value will be the horizontal leg on that triangle. So you need to know when to attach a positive to your X and when to attach a negative, likewise for the Y value, and that's what this is about. So there's different ways for you to get this into your formulas and remember what the things that you have to memorize. A lot of these things you can get away from the memorization and be able to draw it so you have an understanding of it. But anyway, when you rotate and your picture's in this quadrant right here, both your X and your Y will be positive because X's are positive, Y's are positive here. When you're in this quadrant, let's say you rotate to this quadrant and you draw your triangle, which will have a horizontal leg, X value, and a vertical leg. Your X's will be negative, your Y will be positive, and so on. As you come to this quadrant, let's say you rotate all the way down here and you end up with an upside down triangle, which will still have a Y value, a vertical leg, and a horizontal leg. The X's will be negative, so will the Y's. And finally, when you get to quadrant 4, your X's are positive while your Y's are negative. Now, sometimes without drawing a picture, they're going to ask you to rotate to a particular quadrant and ask you, and they're going to indicate to you certain negatives and positives by just saying things to you like the sine is positive. You're in a quadrant where the sine is positive and the cosine is negative. Because sometimes they're going to start you off in these problems because you need to know where to rotate to. So they can do that in a number of ways. They can say to you, your central angle is 60 degrees. That means rotate to 60 degrees and draw your picture. They could say rotate to 120 degrees. That means you're over here and you draw your picture. And then you'll know whether your X's and Y's are positive or negative. Or they could say things like rotate to 5/6 pi, where they start talking in radian language. So if they say rotate to 5 pi over 6, that would be in here, which means you need to have a handle on your knowledge of fractions. If they say rotate to 5/6 of a pi, this is 6/6, 1 pi. So 5/6 would have to be in there. That would be a way of telling you what quadrant you're going to land in. But on a more abstract level, instead of giving you a value to rotate to where they're telling you the central angle so you know where to rotate to, they could just forget that and they could just say, go to the quadrant where cosine is positive and sine is negative. Then you're thinking on a more abstract level. Cosine is the X value. So if you know that, when somebody says cosine is positive, you're in a quadrant where X's are positive. If they say the sine value is negative, the sine value, remember the formula, cosine is X over R, and the R is never negative. So essentially the cosine is synonymous with just the X value. The cosine value is the sine value is synonymous with the Y value. So when they say sine is negative, you should be in a quadrant where the y values are negative. Or if you don't like thinking about it like that, you can memorize this saying: all students take calculus. And know that when you write the saying, because this is a device for helping you memorize things, you start the saying in this quadrant: all students take calculus, and then you got to know how to use it. You use the first letter to remind you of which trig functions are positive. The first letter reminds you which trig functions are positive. A for all means all the trig functions are positive in here. Cosine, sine. So all trig functions are positive here. Moving to the next quadrant. See how the word students starts with S? That means the sine value is positive. I mean, I guess there's no need for me to write it again. I've already very nicely written it down here. And then remember, when you do the reciprocal of sine, you end up with cosecant. So this one is intricately related to that. So therefore, sine and cosecant are positive there. Use the first letter to remind you of the most basic trig function that is positive, and then its reciprocal cousin will also be positive. When you get here, see T? Again, the first letter reminds you of the trig functions that are positive. Think of the most basic one, which would be tangent. Starts with that letter. So tangent is positive. This is the reciprocal cousin to tangent, and therefore it is also positive. So by knowing which ones are positive, that means the rest of the 6 trig functions are negative, just by knowing what is positive. So for instance, if sine and cosecant are positive, then every one of the other 4 trig functions, like tan, that would be negative. Cotan would be negative. Cosine would be negative. And secant. These are, I think about the basic function first and then its reciprocal cousin. So by knowing what is positive, you also know what is negative. So think about that. The first letter, though, is only to remind you of the positive one, which then leads you into knowledge of who's negative. Okay, so in this one, the first letter of the word calculus starts with C. So what trig function? What is the most basic trig function that starts with C? Cosine. The basic trig functions are sine, cosine, and tangent. All the other 3 trig functions are reciprocal cousins related to them. So cosine is positive, and this is the reciprocal cousin to cosine, so secant is positive. And therefore, all the other 4 trig functions other than cosine and secant are negative. You can also use that. You'll have to use it in some problems because they're going to make you think about positivity and negativity without telling you where you're rotating to. They'll just make comments about a couple. They're going to have to tell you about 2 of the trig functions in order to get you to think on that level. So after that discussion, we can do numbers 7 through 12 from the outlines. Okay, here's number 7, and let's see. I don't think I pointed this out. I did not point this out. I was busy explaining the positives and the negatives. Here is your first serious batch of formulas that you need to memorize. So you have learned the formulas thus far in terms of X and Y and R. Now you're going to learn how to define these trig functions and then getting you ready for chapter 7, which is all about these type of definitions and doing substitution with these definitions and doing like little proofs or identities. We're proving identities. So you have to know all these definitions. So tan, instead of being defined as, it can be defined as y over x when you're doing calculational type problems. But if you're doing proofs and any kind of identities, you're going to want to know it in this form. So tan is also defined as, remember, sine is synonymous to y, cosine is synonymous to x. So using trig words to define tangent, it's sine over cosine. You want the cotangent definition? Just Take this definition, flip it over. So cosine over sine. If you want secant, remember cosecant and sine are reciprocal cousins. This is another way to write a reciprocal. 1 over whatever the trig function is that is a reciprocal cousin to cosecant. So remember, when we were doing calculational type problems in section 6.2, we would do the sine value first, and then we would just flip it over. So you can also say that cosecant and sine are related by writing the reciprocal of sine is equal to cosecant. Likewise, secant and cosine are reciprocal cousins. And like I said, in section 6.2, we would do the cosine value and then just flip it over to get the secant value. But you can also write it like this, using trig words rather than y's and x's. Secant is the reciprocal of, we write the reciprocal as 1 over, and then name the trig function that is the reciprocal cousin to secant. These two are related in a reciprocal fashion, just like these are related in a reciprocal fashion. This one's the easiest one to remember. We always remember that cotan and tan are reciprocal cousins. Remember with these pairs right here, one starts with a C, the other one starts with an S. Likewise right here. And we write it as a reciprocal of tan. You could also write tan is equal to 1 over cotan. You can put whichever one you want here, but then the other one's going to go here. Likewise here, you could put sine here and cosecant down there. These are the Pythagorean identities. But instead of what you've been used to seeing your whole math career, you are used to seeing a squared plus b squared is equal to c squared. Well, when you're in a unit circle, it's x squared, it's y squared plus x squared, or vice versa. You could switch these around. It's x squared plus y squared is equal to r squared. This is the r in a unit circle. This is the x, this is the y. So Pythagorean theorem using trig words can be written as sine squared plus cosine squared equals 1. And if you take this equation and you divide everything by sine squared, you would end up getting this definition. Now, I don't know that you want to get into thinking about it that way every time you need to pull out a formula, so I would just memorize these formulas. This one is tan squared plus 1, while this one is cotan squared plus 1. This is related to when you go tan squared plus 1, and with respect to these Pythagorean theorems, it's equal to secant squared. And then cotan squared plus 1 is equal to cosecant squared. Memorize those. We're going to be using those over and over again. Okay, now we can go on to numbers 7 through 12. Okay, complete the sentence. Sine squared plus cosine squared. That's one of the Pythagorean theorems we just looked at. That's that. Determine if the statement is true. I would just write it myself. It's easier to do it like that. I wouldn't look at this right now. They're doing a reciprocal deal here. Here's secant theta. What is secant? Who is secant of theta related to reciprocally? Cosine. These are reciprocal cousins, and then see if that matches. Nope. They gave you the wrong one down here. So it is what they gave you was a false statement. Number 9. Use the properties of trig functions to find the exact value. Do not use a calculator. So you're doing the sine of 61. So what you could do is you could rewrite these in their reciprocal form. What is related to sine? The reciprocal of sine, using these kind of definitions right here, we learned that sine and cosecant are reciprocally related. Sine and cosecant. One starts with an S, one starts with a C. So you could take this and write it as 1 over cosecant. That's the same thing as sine. So I'm just rewriting this in a different way, and then just put whatever the angle is that they used here. That's being multiplied by cosecant of 61. So you actually have in this problem cosecant of 61 at the top over cosecant of 61. So your answer turns out to be 1. We'll pick up with this in the next video.